Hello everyone, this is Dr. Lashik. This lecture we're going to talk about ways to measure variables and also scales of measurement. Alright, so we're going to start off by talking about the three main ways we measure variables. However, before we do that, we really have to revisit the difference between operational definitions versus conceptual definitions. Alright, so before this point, you've either heard a lecture about the difference between operational definitions and conceptual definitions, or you've read in your book about that difference. And let's revisit those concepts. The first one, the conceptual definition, is the idea that we are trying to study at a theoretical level. For example, if we have a conceptual definition of anxiety, our conceptual definition might be anything like a person's general unease about life. That would be considered a conceptual definition. It's using words to describe anxiety without giving anybody any way of measuring it. Whereas an operational definition is one that tells us how it is measured specifically. For example, again, if we're trying to define anxiety, we might define it as the number of times a person paces the floor per hour. Our operational definitions don't necessarily have to be all that great, meaning that might not be a very great way to measure anxiety, is counting the number of times a person paces the floor. However, it does give us a very concrete way of measuring it. And you'll hear about later in this chapter about ways in which we can check the reliability and the validity of such measurements and such operational definitions. So it's really important for researchers in psychology to come up with operational definitions, because much of what we study is an abstract concepts. So before we are able to come up with an operational definition, we often have to refer to our conceptual definition. So let's say we have a conceptual definition for happiness. And our conceptual definition, like it shows in this slide here in the cloud, is subjective well-being. So it's just an abstract way of thinking about happiness. So when we're coming up with our operationalization of that construct, we have to think about that conceptual definition. So for instance, since our conceptual definition is subjective well-being, maybe the best method for us to measure happiness would be through self-report. Since again, it's subjective, maybe simply just asking the participant if they feel happy would be sufficient. And that would be one of the ways in which we might measure our variables. And the three main ways are through self-report, observational, or physiological. And there's an example on the slide here of all three to measure happiness. The first box, the 5-item scale, is an example of self-report. The second box, number of smiles, would be an example of observational. And the third box, brain scan, would be an example of physiological. Alright, so most variables can be operationalized in many different ways. There's almost never one set way you can measure it, and only that way exists. Again, we can come up with lots of different ways to measure anxiety, but some are probably better than others. A good example of this is something as simple as gender can be measured in many different ways. The most obvious way to measure gender would be having somebody take a self-report survey, asking them if they consider themselves to be male or female, and then seeing what they respond. Quite simple. Another way might be to call them up on the phone and judge by the sound of their voice through observational methods whether or not you believe they are male or female. Again, one is probably much better than the other and probably makes a lot more sense. But my point is that there are many different ways to operationalize a variable. All right, let's talk about the self-report measures in more detail. Again, that's any way a researcher asks someone in a survey, and this could be a verbal survey like over the phone, it could be on a piece of paper, it could be on an internet survey, to report, so self-report, self-analyze a specific behavior or trait. For example, if we're interested in measuring stress, we might give them a survey, and one of the questions on that survey might say, how stressed do you feel? And they answer it. The second method of measurement is observational measures, and this means measuring observable behaviors that represent the concept of interest. For example, if we're measuring stress, we might, instead of asking them through self-report measures, we might record how many times a person paces the room while completing a difficult task. So that's the first way, direct observation, seeing the stress as it exhibits itself. However, there are other ways that are a little bit more indirect. An observational method also might measure the physical traces or evidence that the behavior had occurred. For example, again, let's say we're measuring stress, and we believe as researchers that a good way to measure that is to observe how many times a person bites their pencil. And you can literally count the amount of stress they have by counting the bite marks on that particular pencil. Again, probably not as accurate or good as a different way or a self-report method of measuring stress or a different method, but it's possible. Maybe that is a way, and that would be considered an observational method. Another way might be by measuring the external events that had led to that concept. So again, we're still talking about an observational method. Perhaps we know through our previous research that if someone experiences a lot of traumatic external events, they are more likely to be highly stressed out. So we count the number of traumatic external life events that they have experienced, and therefore we can predict with pretty high accuracy how stressed they are. That again would be an observational research method. The third way in which we could measure a variable is through physiological measures. This means measuring the biological reactions that are a part of the concept of interest. For example, again, let's say we want to measure happiness, and we are trying to do so physiologically. Maybe we might measure the muscle twitches in the face that are associated with happiness. We might measure the brainwave patterns of happiness. All of these methods usually require some sort of fancy equipment that tells the researchers that the physiological event has occurred. So typically the physiological way of measurement is not through observations with the naked eye. For example, let's say we're measuring stress. We might measure the brain patterns associated with stress. We might measure the heart rate increases that are associated with stress. Or we might measure the cortisol level increases that are associated with stress. All three of those methods require equipment and are considered physiological methods. One physiological method that is used frequently by psychologists is using an fMRI machine. These are brain scans that show where more blood is located in a specific brain region in real time. And this works under the assumption that if there's more blood in a specific region of the brain, it means that that particular region of the brain is working harder and being used than the other brain regions. So they might have a participant sit in the fMRI machine and ask the participants to think about or solve problems while they're in there. Then the output, or what the experimenters see, is a display in real time of what parts of their brain are being activated during which task. Now we're going to change topics for a little bit and talk about scales of measurement. All variables have at least two levels. That's why they're called variables. They vary. They must vary at least to one other state of being. And all variables that we study in research fall into one of these 4 scales of measurement. There are categorical variables, or the 3 types of quantitative variables, which include ordinal, interval, or ratio data. So let's start by talking about the difference between the main 2 categories of variables. Categorical versus the quantitative variables, which again include ordinal, interval, and ratio. Categorical variables are also known as nominal variables. So if you take a stats class in your future and you hear the word nominal variables, it means the same thing. Categorical variables are defined exactly how it sounds. It's categories of a variable, so categories of information. Researchers, when using categorical variables, will assign numbers to categories, but the numbers that they are assigning are completely arbitrary. For example, let's say we are studying a group of monkeys, and we have 3 different species of monkeys. We have rhesus monkeys, macaque monkeys, and howler monkeys. And when we're done with the experiment, whatever we've done, we are analyzing the data. We arbitrarily assign numbers to each of these monkey species. Now, let's say we say rhesus monkeys are number 1, macaque monkeys are number 2, and howler monkeys are number 3. But these numbers that we've assigned don't mean anything. They're just arbitrary signifiers that represent that monkey species. In other words, howler monkeys, even though they received the number of 3, do not have any higher value than rhesus monkeys who only received a number 1. We could have just as easily assigned the number 3 to rhesus monkeys and the number 1 to howler monkeys, or assign the number 1 to rhesus monkeys and the number 3,000 to the howler monkeys. It really doesn't matter. So in other words, the numbers that we've assigned are arbitrary, does not matter. Other great examples of this in psychology are gender, so males can get 2, females 1, or vice versa. Political party, hair color, these are all categories of information where the numbers that are assigned to them have no meaning. Quantitative variables, on the other hand, are when we have variables where the number that's assigned to them does matter. So if we have a higher number of something, it means that there is more of that thing. A good example of this is weight. If we have the lower number when we are discussing weight, it means there is less weight there. Another good example is taking a survey where you have the option of scoring 1 to 7. If you score a 1 on that question, you have less of that construct than if you had scored a 7 on that question. So quantitative variables, the number that's assigned to whatever your answer is, or whatever it is, means that there is more of that thing. So let's talk about now the 3 different types of quantitative data: ordinal, interval, and ratio. Ordinal data means that we're looking at ranked numbers. So when you think of ordinal, think of the word order, right? The order matters. But despite that, we are not sure if the space between each ranking is equal. Let's go through some examples. Let's say we have a list of the top 10 highest grossing books of all time. And we know from looking at this list that book 1 sold more than book 2. And we know that book 2 sold more than book 3. But we are unsure if the difference between book 1 and book 2 is the same as the difference between book 2 and book 3. For instance, book 1 might have sold 3,000 copies in the first 5 minutes of being released. And book 2 might have sold 2,999 copies in the first 5 minutes of being released. But book 3 might have only sold 5 copies in the first 5 minutes of being released. In other words, the space between ranking 1 and 2 is different than the space between ranking 2 and 3. We have no idea if they're consistent or if they vary. Other good examples of ordinal data are the order of runners who finished in a race. Maybe the first place winner finished, and then in milliseconds later the second place winner comes right up behind them, and then an hour later the third place winner comes up behind them. So again, the difference between milliseconds and then an hour is different between the different ranked orders. Another good example is gold, silver, and bronze medals awarded to Olympians in the Olympics. Interval data fixes the problems of ordinal data in that while the ranking and the order does still matter, the spaces between each ranking are equal for sure. However, the catch with interval data is that there is no true 0 point, and I'll define what that means in a second. No true 0 point means that a score of 0 does not mean that there is an absence of that construct. For example, most typically we consider Likert scales to be interval data. So Likert scales, again, are when you have a question on a survey that says, pick your response ranking from 0 to 7. How anxious do you feel every day? That would be an example of a Likert type question. So it's assumed when we're thinking about Likert type questions that let's say we have a scale from -5 to +5. We would assume that the distance between a score of 1 and a score of 2 is the same as the distance between a score of 2 and a score of 3, so the intervals are the same. But if we scored 0, it does not mean that there is an absence of that construct necessarily. For instance, again, we have a ranking of -5 to +5, and we are asked how much stress do you feel in a given day. In this case, we would assume that the distance, again, between 1 and 2 is the same as the distance between 2 and 3, but if we scored 0 on that, it probably would mean medium stress. Maybe a score of -5 in that case would be very, very low stress, and a score of +5 would be very, very high stress. Another good example is, what if we had that same question again, but it was on a scale of 1 to 7? In that case, 0 is not even an option. So again, there's no true 0 point. A great example of interval data is temperature. We assume that the 1 degree difference between 5 degrees and 6 degrees is the same as the 1 degree difference between 6 and 7 degrees. But 0 does not mean that there is an absence of temperature. It means that it's really, really cold. And finally, ratio data is the last type of quantitative data, and it solves the problems of both ordinal and interval data in that it is assumed that order matters, so the ranking matters, and it is also assumed that there are equal intervals between each rank. And finally, it also assumes that if we have a score of 0, it means there's an absence of that construct. Some great examples of ratio data are weight. So if something weighs 0 pounds, it has no weight. Or height is another good example. If something is 0 inches tall, it has no height. Another good example is scores on an exam. If someone scores 0 points on their exam, they received 0 correct answers. If you have any questions about anything we just went over, please don't hesitate to email me. Again, this is Dr. Lashek.